no brown stuff. When I go, I if I begin from Poland, from the wisdom is Poland Warsaw is some here, so if you land in Warsaw, then you can take a bus or take a train, same people. We start the show to you about this our film. One minute I show you I think about Białystok what maybe all but the fragment of this. Because unfortunately I don't have the latest version of this film and it's we have the director was changing at our university. So,
Podlasie. Thousands of hectares of forest, numerous lakes, vast wheat fields cover most of the earth. One of the largest productions of healthy milk is located here. It is here that one the center of this magnificent region is its largest city, Białystok. It is here that one of the greatest and most prominent academic centers is located. This is the home of the Białystok University of Technology. Białystok is a culturally diverse city with its own opera house, philharmonic hall, numerous theaters, musical clubs, places one might want to visit while staying here. With its vast historical park complex, Białystok is known as one of the most green cities in all of Eastern Europe. Białystok University of Technology is located close to the city center. campus is connected by a complex network of roads, public transport, and other means of getting around the city. With an area of 31 hectares, the university stands open to the residents of the rooftop, allowing them to use the campus as a place for relaxation and recreation. The university took its first steps in the year 1949 as the private evening engineering college with its mechanical and electrical engineering
Yes.
levels of education. Currently, there are around 10,000 students enrolled in various courses throughout BUT. From architectural engineering to forestry, students study a sum of 5 years during the first and second degree courses. The university currently takes part. The Summer School of Logistics is a very important part of this program. Both Polish and Chinese students have a great opportunity to study and to get to know the culture and traditions of the foreign country. Students from the Białystok University of Technology form their own organizations such as research teams, science clubs, and unions.
Organizacje studenckie w znaczący sposób
While most prominent science clubs perform extraordinarily in terms of international competitions. These include top places in University Rover Challenge, European Rover Challenge, Formula Student, Microsoft Image.
I think we can to our question. You know where from. Who am I? I'm a teacher at Faculty of Computer Science at the University of Technologies. I'm focusing on teaching operating system and environment. And my research is primarily concerned with algorithms for the test. Maybe maybe a key first section of this presentation. Because what is memory RAM, everyone of you know, I don't have to define what is RAM. Maybe move to the second section of presentations. Maybe stop on this slide. What have we wrong from the there's many reasons that now we have that part, but not only in our mom. Even if such problems are like problems which not describe this problem. In 2009, explained by error or software error when they said it was was the reason when things it's true. What impact of wrong finance on our system is, that's obvious. The situation that is, but the impact is very big because you have finance lead to application which is called data loss. This is normal case, but not dangerous is are silent errors. The silent errors are especially dangerous in critical system. What is silent errors? Silent errors is something like if there is fault, but we don't know about this fault. For example, if cosmic rise, for example, change switch the bit in our memory and our function, our critical system returns that value, and we don't know about this fact, then there is a big problem. Because if you look about our flow, our areas, problem, but this problem is small, okay? But if we don't know about this problem, big. When it's like most older, like to see the electronic devices, not all electronic devices. This testing during manufacturing, somehow when you turn on a computer, the program is tested. And during runtime, this kind of test is called transparent monitoring test. We focus our presentation on this on this two kind of test. Then we can move to conform models and consumers. Digital signals can be tested or are tested on different level, different structures. Electrical model, electrical model, functional model, and general. We focus for normal devices, the most common approach is testing based on front model. We know how the memory should until we compare what we from the memory from what we need from the memory from the one which we are should expect to read from this memory. It is from fact. And for us, it's not. It's we are not interesting. In fact, that's why find out the Google's translation of fact. It's not important. As it is simple. And we focusing in on testing on functional model. Uh, there is Uh, there is on the slide, you will see simplified function found there. You can observe three blocks. Blocks of the block of parts of one analysis. So, if you see analyze, you can see your plan there, like so, like it's the second one is the numbers of that one. Down the title in the left hand, which writes from my footage. And this is even more simplified. Than other. Yes. So they call the memory cell address, one side to the right, and the right. And I think on this on this model, we can define numerous foods which we they want to actually want to fight in our mouth. Different, the different problems that the physical level can cause bring the same result. So we find we don't want to find physical problem, but we want to find we need to decide the question uh, is wrong is what is happening is not right. And just as there are many different things of problems, that's like we replace those sometimes for transition fault, company fault, other sensitive faults, it's collided with memory systems stuff. There is, for example, there are many things connected with others decoder block and read write block. It's after or it's not short. Others the decoder block. The way in our language, those of all connected, especially with memory and for what it means values some balance zero recognize one we check we don't we, we can't change the value of this so it's always easier. It's something like sympathy but we can change the value from, for example, we can change the value from 0 to 1, but we can change the value from 1 to 0. So it's very, it's like, it's unfortunate, the value. Involved more pattern sensitive faults, faults connect two or more cells. For example, condition in one cell and the total over the cell. If we have two cells, for example, you have an analogy. If we switch the value in one cell, then in the second cell, the value will change to. And to be sensitive for this happening fields, persons sensitive fields, um, define patterns. We have, for example, five cells. Okay. One of this is base cell. And then if one of the biases. Brains. When if there is a special pattern, for 0, 1, 0. Then how we change, for example, from 0 to 1. But this works correctly in separated environment. There are interactions with this can then start and specific force is one of the it's one of the different is the employee. There are interesting types of this form. It's because I have what sensory force with four languages. That's also Luigi method. Luigi method. Sempre it's exactly. No, actually. This flows are for towards the effect of all the policy combination. The differences should be as a big as but this is all because the competition. So the overall is but the problem is the source of optimization problem is the dancing. Because if we think about memory computer, think about time. There is 1, 0, 1, 2, 3. But of course, it's not real. So of memory, okay? Because memory is placed on a silicon area, and this area isn't real. Okay? So, during the production of memory, is about optimization. And so, optimization. So, this is of our memory. And this is logical to define our memory. If we always see like that, but we don't know what is physical name of the cell. Yeah? Because we look at the memory the logical type by the logical type. This so cool. But the problem is we still want to have our devices so smaller and smaller and smaller. Then we have to use advanced technology to produce our chips. The chip should be smaller, and smaller. And very cells are closer to each owner, and physically closer to each owner. One cells influences to other cells. So, but may can influence to another cells. No logical level. here is problem which we don't know very matter, which, for example, help us to uh, this thing, we don't know why start apply. To which sense should we apply our path? In the form we use investment more. Yes. But this can be mentioned in the standard patterns, the pattern sensitive code. According to this definition, we can say that any car out of n memory cells, where n is the total number of memory cells, are considered. So, but in these house, but we obtain that the result obtained from PSF can easily apply to all the four connects. For example, because we can define, for example, PSF, then we will say about the say connect other sensitive for all of us, and then when can you see more physical why do we need specific physical this is let's talk about algorithm. First of all, some historical algorithm. Well, instead of zero one algorithm, this is simple test to do this like zero to all sense because so it's like zero. There is another value than zero. Then that the procedure and that the procedure in this is so. That's like one to all sense, one to all sense extent. So it's very simple. It's something substantially this in this regard. So this algorithm is it is very important in testing memory because mm, we can't use other algorithms in a real memory testing procedure. We can't use another but another with depends with complexity in modeling and because the present timeline recognize and memory to today's memories are very very big and I like maybe a slide the time which is need to detect detect something. And then the historical is working zero, one, zero, and pictures so in the rest of cells we integrate this equal zero. Then the rate will be generated and then compare this if everything is okay. Here the complexity is too big. We can't use this algorithm no. What of the best historical around this is that it's it's like working one zero the complexity and what we can't use this test to play this customer. Why historical tests are not enough. Uh, if we compare the test with like linear complexity, and we think that if you like to test, for example, gigabits of memory, then we need about five times of units, which is not acceptable for tests with real complexity. I want 50 seconds. This is actually it was time for memory operation. And so I will try this. This is only tomorrow. Yes, the term is equals operations. So we can't use another test than tests with complexity also with another complexity because it's not real to test with memory with once the time solution is efficient testing with complexity. This one is often by large tests. Large tests are what I use because I like the only test used today, which I widely use due to the simplicity and effectiveness. What is March test? Uh, March test is the most practical solution for testing around. And they use due to regular complexity before and for built-in self-test based implementation like built-in self-test for everything what is built-in self-test. Self-test is if we reduce, for example, that system, then we build into this system test procedure for the system. And when we start the system, this built-in self-test run and check all kinds of system. We call this kind of implementation as built-in decisions. Small example. Here, this is describe the notations which we used in March test. Some sort of March sequences operate operations apply each analysis. So March elements we have here large elements, and we have sequences of right. Right. So we have this here leads by the achieve of the the sign means environments when we are our place. The upper row means 0 2. And one number means let's say from n to 0. Right? 0 means 0 to the side. And 0 0 when the value from the set we compare it with 0. Okay? This the first price. So for line was simple size again is size on the memory with 0 in the sun. When you move to the price, the second price remain five 0 to n plus and see on the next 0 to 0. That's what I'm sorry about that. I have no idea. That's very interesting. There's slots, missing slot. So, oh, right. Nice. That's the one. So it's fine. That's the once others are from 0 to 7. It's no if it's contents. It's not contents. It may be it might be random. Then we start with this suffice. So we have 0 to percent in our uh, and we bring this house and then write 1 in the two next step. To the first, first, we print 1 and write 0. Print 1, write 0, no, write 0, but the arrows on the left and middle pointing up, and the other was down. However, this one is pointing down. But it's doing the same thing in the animation. In real life, it would be opposite. It's coming down. About the one was doing from bottom, in this case, address wise, just doing it from 0 to 0. Yeah. Which is correct. So that one, yeah. Because I explain it in the next slide. I will explain in the next slide. How I have. It's not only one large test. There are many different large tests. For example, here is up, is down. Here is up, here is down. It's depends on the test. If I find out on the test plus something because it's very important. Yeah. For example, if we start over, it's the content of our method, right? It's other 0, 1, 2, 3, 4. If we start from 0 to 4, we generate 0 in our manuals. When we change here one, so generate pattern is 1, 9, 0, 0, 0, 0. Then the next pattern will be like this. Next pattern will be like this. The next pattern will be like this. The next will be like okay. Usually start from 4 to 0. So the united will be 0, 0, 0, 1, 0, 0, 0, 1. So another place 0, 0, 0, 0. So there are another pattern that is generated. If we compare this set of patterns and this pattern, we can see that some patterns from this and this set are the same. Some are the different. And different patterns allows us different patterns allow us to detect different nodes. Okay? So therefore, it's very important if we go from down to go up, or if we go from up to down. If it doesn't matter, something like that, because the performance isn't one. Perhaps if we write 0 from 0 to 1, or write 0 to our size from 0 to 1 to 0. Okay. So, there are many different March tests. If we see about full coverage of those tests, you can see that March test cover for symptoms. This means simply the four symptoms are need for those connected only with one cell. I call this simple. Second one, other the color flows and third foundation flow. There is some problem with coupling faults because coupling faults is relevant memory. Memory access. There are much famous tests that cover most coupling faults. The problem is with link and false. And what is link and false? Link and false. Uh, it's the fault. For example, if two happen for if two have collected from happening fault, for the situation, um, for the situation, studying so you get so yeah. I much less, I said that much less are the best test for today for today's memory. Today's memory, but much less comes limitations. What are the limitations of March test? March test can only generate a limited number of patterns across the whole the memory cells. It's not the third number of those files on the operations in this place, we are not able to do more than like patterns. A pattern for 1, 2, 3, 4, 5, 6, 7. Because of regular structure of our March business, we will ID traditional market generate more than eight parts. So that's why this test it's in its traditional version is not good for sensitive faults where we need to generate as many patterns as possible. Uh, now let's move to testing. This transparent testing. It's interesting. Uh, Testing, the transparent tests are useful when the system can be stopped or stopped. And transparent testing, so test the system before the system start critical things for us. We don't need to stop this system. How test we can use standard March test because in standard March test, the first phrase is always right 0 to the memory. So if we have this type of our system, then we will write we limit what comes is in our we consider this for example in this when such when we turn on for example computer put them under the system, then we can use this. But we can't use it in a case where the system is running. You can imagine that we can copy all the contents of the memory, for example, to disk, and then test the memory, and in the next step we can load the contents of the memory from disk. But it will need a very long time for copy. We can do it in this way because we need to know if we copy the contents from memory to disk. We need to know that the memory it's a program. This is something like a program. We need to know that the memory around correct. So
And if the memory is faulty, then it might not actually be a perfect copy. We're testing for that. The memory is faulty.
so in some systems, for example, if we think about PC systems, we can imagine that there is this. For example, in a car, in the medical devices, this, we are not able even copy this data system. So we need to have another solution to this problem, and it's help us to solve this problem. The transparent testing helps us to solve this problem. What is key features of transparent testing? First, doesn't algorithm data or the contents of automatic for real-time and mission critical system, because you can run the system the moment the moment when the system when we want from the system plus the critical system steps. Start if you want to know that system is perfectly is correctly for sure. If you want to this is information. We can start with what was the key idea of this task. The basic principle is that during testing, the data stored in memory is inverted and even number. Okay? Yeah. It's the key idea of transparent testing. So after even number for inches, the value always return or original state. Uh, why transparent testing use its tool? Because the today, the hashes are the only memory tags that are actually accessible to today. And so there is arguing that accounts are from the traditional March test to transfer. And after conversion, after this algorithm, one is divided on two parts: prediction of place and a test. You can see that instead of zero, instead of one is negation. So what's the idea of this test? The main idea of this is that it's not like during the prediction test. So this prediction test is based to this test. This is the same like this test. But we delete from this test now. Because only is there are only in prediction. In prediction. We start we start prediction of price price like signature of current state of memory. One is to see logistics. We know with each operation, we use to calculate signature and after this task, we compare these two to the results. It's the same like you sometimes download program from the internet. Yes, the very same task. And if you download this program from the internet, you can calculate the hash on your computer and compare it with this tutorial.
How big is this test that you can fit realistic? Say for a gigabyte memory computer.
Do you mean size?
Yes, installation.
It's depend on the algorithm which we use to calculate it, but it don't need to be too big. It, maybe 128 it's for example enough. Why we calculate this hash in memory system? We usually use representative logistics. Representative registers in the the values. Calculate and calculate signature from our memory. Let's start with our conventional advice. First, we run this space, and so we need to various our memory. So well, sent to our sent select to the first our professor images. And we need one round sent our plan register and means so. Excuse me. Right? No. Here.
The exclusive order.
Yeah.
Like a cross. Shot. Product. The shop. Extra elections. Check side. Makes sense. So it's the same. 1.0.
Yes. 0, 0, this is 0, 1, and 1, one over here. This one. Okay. And now we move to the second phase. Right? Okay. Do the same. No, it's right. This value see not button is the matches.
Okay. So if it's not the same, we want to be.
Yeah. So that way one power does. Because here was only finished. And we assume that with operation don't want to use the code in now. You know? The read operation is not the source of the code. Okay. And now we start read task where we use the right operation as well. We use the right operation to change the value in the memory. We change value in the memory, then we can detect there is something wrong in our memory. Not in the moment when we are changing, when we're switching the memory, but after that, when we compare, we
You compare, it's not the same at all.
yeah, if they are not the same, then will be, this means that there is fault in our memory. For example, if we assume that uh, here is, for example, a second fault, second one. The second one means that we can change this value from 1 to 0. And that is always 1 in this memory. So this one really serves to our understanding. Yes, the value will be what? Okay? There will be second code in this this value uh, switch. It should be
So it's a transition fault. So,
yeah, it's very similar to the transition code. It, for example, we can assume that here is the transition fault, the transition fault that we can change the value from 0 to from 1 to 0. But in this case, the same there is separate fault, it's always 1, for example. If so, what? Not 0 will be sent to our register, but value 1 will be sent to our register. Well,
yeah.
and this value will change, and if we compare those register, this moment the ones are the same. If we send from the third from the third instead of 0, just this value will different, no will be different, different from the from the sense. And first time testing, apparently, verification for activities in the conference, all the most information about factory testing. I get in the previous slide. So I want to repeat this info. But you need to know that there is still March test. There is still March test, and you remember that March test 30 days. Yeah? They are not able to generate more patterns, but you need to notice one thing.
Yeah. Guys,
So, I think it's right. It's an intention of March 1st, one again. But I will multiply first activity. Therefore, we need to generate as many patterns in nuances as possible. Always so that my test generate only a limited right now. Firstly, about if you are talking about um, transparent, the transparent test, that let's imagine it will focus on memory will change. For example, we have two cases. In one cases, we memory, we initial sequence we memory with all the zeros. We use only one space. What kind of patterns will be generated in those three steps? Will be 0, 0, 1, 0, 0, 1, 1, 0, 1, 1, 1. Then we use the same test in the case 2 when we fill our memory with 1, then we have another pattern. Yeah? So if we imagine that we have computer, then we have RAM. Complex in RAM is still changed. Yeah. Then if we run our test in in this moment, then will be generated set of patterns. But if contents of the memory will change, then we use the same test, but patterns, the generated patterns will be other. Yeah. Okay. But it's the next. So we can use this approach in computer as a part of operating system. You can imagine that we write Python. It will be our system from time to time. It can run very short tests. From time to time, can imagine that the system will be test. Another approach is that we use multi-run tests. So we run the same not only one time. For example, but we have to change background. We have to change contents of the memory, but we need to do it in such way that after testing we return
Those we can't do transfer numbers because the contents of the memory might change while the user is using the data.
No. Because if you use when we system for example, system second,
Yeah.
and then we change the memory, we test the memory, then we test to use an application. So it's interruption. But if we want to use this approach, then here's another problem, which background should be used. Um, if we but background. It's finding it's not just quality islands. In fact, iteration of this test with background only one 0, 0, 0, 0. Then the second three iterations from different background, from different contents of memory. And notice this that we very different fault coverage. So, the value of the test is strongly defined in the diagram. Of course, in transparent testing, we not write those background to the memory because this is time will delay the context of that. But we can use this diagram as mask to our memory. So, if, for example, the memory is the contents of the memory is 0, 1, 1, 0, 0, and 0, we use such mask, for example. The use our backgrounds as a mask.
So imagine modern personal computers don't do it at runtime, they do it at.
Sorry?
So I imagine modern personal computers don't do this test at runtime, they do it
Standard personal computer in BIOS has been implemented so easy, so very simple. If you enter to BIOS and start full memory test, then it will the most use then it's much easier. Sometimes it's in display which kind of test is used. Much minus no, no,
Okay, what's not much fun?
It's my much it's one of the most popular that and we discuss is in most program and guiding allowed us to test our language. It's not always run because when
Yeah. You know, just to change it, like, oh, it's just for one. I think of the animation is really different sides.
March, if we like if we use March test, simple March test, it will take about 200 to 200 seconds. So if we have our computer, we don't want to wait to 200 seconds. Then yeah, it's going to take about an hour. Yes. So, if you don't pass our computer, have around our task. So, the external power.
Just would have to run at OS level.
Yeah.
Oh, no.
Oh, I'm not remember this.
Maybe you just use a live image.
Well, think about control around random test. This control random test maybe in this picture I will try to easy to define the control random. Here we have a set of random. By random type, we think about random test. We think about a random base, not random test, for example, March test, C plus, March test, March plus, March plus plus. No, no. We use the same test, but we will different different inputs. The diagrams are completely random and control random test is something like random test graphs isn't completely random. Right, the next diagram depends on the values. Right. So we can our one here who's on generating such backups then has to generate as many packets as possible. So no, we will use maths class test, and we want to generate as many backgrounds for example, we can think about and we want something there can be there can be eight yeah, it's possible to generate eight maths. And but we need to take into consideration we see about Switzerland, you know, which purposes. In one, you remember utilization problem, huh? Yes. Optimization problem is that yes, it's silicon area. Yeah, and because it's something that it's the problem. Because the pattern sensitive fault it's yes, like this. But we not know the members of physical labels of this set. So we should rely as many patterns and as many patterns as possible in any training set. For example, 0, 1, 2, 0, 3, 4, etc., etc., etc. And here is this is a problem how to do
Wouldn't manufacturer which physical positions correspond to logical addresses?
Okay, but we don't know physical position. Only maybe at the stage we know the physical stage. But normally we don't know this information about the physical stage, about physical position of our students. If we know this information, I'm sure we would use. And apparently, multi-round testing are composed with transparent tests, match tests, and controlled around match and then controlled random tests. If we connect those three elements, then we can multi-round and march test. We don't always have time to run this test because it takes many seconds, but sometimes it's very important operation that we need to that we have to know if the memory works okay. And since then, because another lecture they can be about control random testing, they can be about how to generate this pattern. This is there are big problems. I only yes, I want to present. I would like to present the problems to you. I want you to understand the problems that I appear when we test when you want to start. Yes. It's a summary from the lecture. Rather than this essential something of the story. Our models guide this design evaluation, marginally provide efficient structure testing, transparent and multi-run testing, expand code protection coverage, initial memory content address sequences in one speed. Instead, for example, instead of generating different paths, we can change address. We can change address because uh, it would have it means is minus uh, 1 0. But but we can change it. For example, we can use this memory. So up arrow, we can so for example 0, 2, 1, 4, 3. Down arrow, we have 3, 4, 1, 2, 2, 0. So if we change the our cycle, will be the same if we change what line.
So instead of looking at the patterns, we're looking at the threads at cell scale, the second individuals, the results.
Yes, it's from the large test, from point of view of large test, it's not important in the sense with the use this or not. Very important. But the exactly inverse of the fact. So to generate our request, we can use initial memory content address sequences significantly by address test attacks. Something like that. If we are here, if we put background selected, we use to here, just select. The final results will be different too. Like this example. Thank you.
Sure.
Constantly done by mail, by professor. If you will add something, ask something, wow. Question, but the question was on
Gabriel's
So many of these algorithms can seem easily reliable, especially the linear complexity one, like the first one, the first orange. No, not the March, before the March, that's the one complexity one.
do you mean the historical?
No, the right one, where right one and then check if you're that one. Sure, it's yeah, 0 and 1. The variant of this is shown that's over one square. That one, I eventually are different to the next of the number. By doing parallel.
Yes, it's but you need to see that fault coverage in this test
Yeah.
is very small. only some four types are the text. First of all, second false. False, by default. But if you think about the next one, for example, about this one, if you want to divide our memory for segments, yeah, we can do it, but you need to remember that segments between segments can be connected with poles. Okay, with pattern sensitive poles. And first of all, in real time, we don't use external program to tell the memory. We use this algorithm especially in embedded system. In embedded system, we usually have only one processor. And we can run on this usually we are not able to run many threads into this processor. So we not able to run parallel to this thing. But in sorry, in some situation, of course, it's possible when especially when segments of the memory will be on the chips. Yeah. Yes. Then the won't be won't be in one code.
Yeah. Okay, thank you.
Yes. Yeah. Yeah.
When how storage technology has evolved and how we are using now SSDs, do these techniques get used in SSDs as well?
No. No. This is no. It's not. This technology is not used to any to this. It can be used, for example, it can be used in SSD disk, but it it's low. It's very slow because we can imagine that we use something like that. The same in such like this. We can use it in this devices. But it's very important because embedded systems, we can build this task into system. Here we need to use external system. But of course, you are right. This type of test can be used in assembly systems using like. So thank you. It was very nice to meet you. We invite you once again to visit the wisdom. The thing that makes me play is to buy Erasmus program for one semester. We have we can choose network, for example, for example. Yeah, like just I feel any questions?
I don't think
Thank you.
Before we close everything, I was writing. I'll put the book easier first. First and foremost, I want to thank everyone that's here today, that took out of their time, out of their week to be here and enjoy this talk. I want to thank Professor Sylvester. He made it possible for us to have this talk, and it made it possible for Professor Andrej and Professor Ireneusz to come here and do the talk for us. We also want to thank, of course, Professor Ireneusz and Professor Andrej for taking their time out of the travel and to come here and spend the day with us, and of course, teach us about stuff that we, of course, don't know. We want to thank our partner City, which made it possible for us to have all of this beautiful stuff here, especially merchandising is special. And of course, I want to thank IPBC, Student Polytechnic Viana do Castelo, for making it possible for us to have this classroom, providing for us coffee break and everything. And of course, above all, thank you to I3 and all our I3 members who are here. Some of them are watching online, and some of them weren't able to come because of exams. It was an amazing day today, and as president of the I3 students branch, I feel very grateful, and I'm happy that today was possible. And to show our gratitude, of course, to show our gratitude, don't mind. To show our gratitude, we made sure to prepare you guys some rings, some merchandise. This one is for because thank you. Thank you, Sandra. Thank you. You said what? Of course. And it's to show our gratitude, and of course that you can remember us when you go back to Poland. And we really hope to visit your university in the future. If the opportunity comes, we'll make sure to take it. Thank you very much.
Thanks for director of this. And all of you, member of I3 Police Super Student Branch, yeah?
Yes.
Thank you very much.
Thank you.
Sure.